ম্যাডাম আপনারা কি আমার স্লাইডটা দেখতে পাচ্ছেন?
জি স্যার।
Assalamu alaikum and good morning, respected ED sir and fellow colleagues. In today's presentation session, I am Nakibul Hussain, a lecturer, Aeronautical Engineering Department, United College of Aviation Science and Management. We'll cover composite materials. That means I'll try to provide a basic information about composite materials and its application. Composite is a material consisting of two or more materials which have different physical and chemical properties. When materials are combined together in a proper content and fashion, it produces a composite with new material properties that are different from the properties of those individual materials used. Salt and water, for example, is not a composite. Salt and water is not a composite because they blend with each other, or salt dissolves in water, so that's why you can't tell it's a composite. Whereas concrete, which is made out of stones or gravel plus cement, is a composite because you can separate out the ingredients which are used to make the concrete. So we can say that in composites you can separate out the materials as they do not dissolve or blend into each other. Natural composites can also be found in both animals and plants. Here you can see the structure of wood. It is made out of cellulose fibers that are held together by weak substance called lignin. So the combination of cellulose fibers and lignin make the wood strong. They themselves, cellulose fibers and lignin, are weak substance, but when they combine together they form a strong structure which is wood. Cellulose is also found in cotton, but there is no lignin in cotton to hold them together, so that's why cotton is soft. Bone is also composite. It is made from hydroxyapatite, which is mainly calcium phosphate, that is hard and brittle material, and a soft and flexible material called collagen, which is a protein. Collagen is also found in hair. On its own, it would not be much of a use in skeleton, but when it combined with hydroxyapatite, it makes the bone strong structure. Making composite. Composites generally have two different phases. One is matrix, another one is reinforcement. The choice of reinforcement is important for the properties of composite, as reinforcement in the composite is the primary source of strength and stiffness. The structural properties of the composite materials are derived primarily from the reinforcement. The reinforcements in a composite are held together in place by the matrix. They give shape to the composite structure and transfer stresses between the reinforcements. So you can see the figures to help you understand about composite. So they are made of fibers or reinforcement plus matrix to make a composite. Composite materials, as you can see, gets the strength from fiber and elastic properties from matrix, and they acquire a new physical properties. It means a unique property which is different from fiber and matrix. Then there are man-made composites. The common ones are PMCs, which is polymer matrix composites, metal matrix composites, ceramic matrix composites. Polymer matrix composites are also known as fiber reinforced polymers or plastics, where the matrix is basically a polymer-based resin, and the fibers which are common are glass, carbon, and aramid. which act as reinforcement. Metal matrix composites, known as MMCs, are basically used mainly in automotive industry. They are a bit expensive than polymer matrix composites. Uh, then there is ceramic matrix composites, which are used in very high temperature environments, and they can be used where there is extreme condition, for example, aircraft engine, where the temperature is very high. We can see the trend in usage of composite materials in Boeing aircraft over the years. Boeing 747, which was launched in 1969, has 1% composite materials in its airframe, and there's 757 or 767, which is 3% composite materials. Boeing 777 has 11% composite materials, and in Boeing 787, the airframe has the airframe is made out of 50% composite material. So you can see the increase uh, in composite materials in the airframe over the years for Boeing aircrafts, uh, passenger aircrafts. So that means the usage of composite materials are increasing over the years because mainly because it's lightweight, and it has a similar strength to that of material to that of metal. So what are the reasons for replacing metals? That means we are using composites instead of metals. So these are the reasons. The first one is durability. That means composite remains serviceable in the environment for a long time as their corrosion resistance, which is why they require lower maintenance, uh, and for that the cost for maintenance is low. Uh, Freedom of design. They can be designed in various shapes and sizes, and can be assembled into different shapes. We can easily assemble and disassemble composite materials compared to metal. Uh, and then one of the major reason is weight reduction, as the composite materials are lightweight, so that's why they're a good uh, choice instead of metal. And one of the primary reason for using composite instead of metal is we have to check whether the gain is more than the cost. If the gain is more than the cost, we use composite materials in that case. So build composites. We can easily build composites by ourselves at home using just three ingredients. There is water, paper, and lentils. First of all, we take a box or a bucket of equal volume. In the first one, we just take water. In the second one, we take water and submerge or dip few layers of paper in it. In the third one, we take water, equal amount of water for all the case. And in the third one, we put some lentils in water. After that, we freeze all of them out in a refrigerator to create ice specimen. The first one you can say is just plain ice, but the second and third one are composite materials. You can say ice composites. Then we can measure the mass and weight or weight of each of the specimen, and theoretically it is expected that the weight should not be um, different. The weight of each of the specimen should be equal, and then we can determine their strengths and compare them. Strength can be measured by applying loads on each of the specimen and finding out the breaking load or the load at which the material fails. Or simplest way you can do is get a hammer and try to break each of the specimen. The one which takes more time would be the strong material. Theoretically, it is expected that a composite material should be strong, but you can find out by yourselves. That was my presentation. Thank you for listening to the presentation. If you have any questions, you can ask, or if you have any suggestion, you can tell. Thank you.